Hello guys! Good day! Isang mapagpalang araw sa inyong lahat, sa aking mga naglalakihan at naglulusugang mga estudyante. Well, the feeling is mutual. Okay, so let's now proceed with our first module, yung Introduction to Structural Analysis. But bago ang lahat, pasalamatan muna natin ang ating butihing Sir Jake sa pag-prepare ng module o ng PowerPoint na ito. So let's start. So let's proceed with the next slide. Okay, so Introduction to Structural Analysis. So what are the contents of this PowerPoint or this module? So let's start first with the contents. So first, we will discuss the historical background o paano ba nagsimula si structural analysis o structural theory. The second one, what is the role of structural analysis in structural engineering? The third, what are the classification of structures? And last will be our analytical models. So let's start with the historical background. History muna tayo, guys. Alam niyo ba na ang So, since the dawn of history, structural engineering has been an essential part of human endeavor. However, it was not until the middle of the 17th century that engineers began applying the knowledge of mechanics. So, through the use of mathematics and science in designing structures. Okay. So it was only during the middle of the 17th century, so kung saan yung mga engineers nagbigay ng focus dito sa mechanics, doon pa lang nila in-apply yung mechanics in the structural engineering. Okay, earlier engineering structures were designed by trial and error. So ano sila trial and error nung una. Pag may mali, adjust lang sila hanggang makuha nila yung tamang design. And by using rule of thumb, based on past experience. Well, sa past naman tayo natututo. Ayun, hindi na ako huhugot. The fact that some of the magnificent structures from earlier eras, such as the Egyptian pyramid, so about 3000 BC. We have also the Greek temples, so that is during the 500 to 200 BC. The Roman Colosseums and aqueducts around 200 BC and 200 AD. We have also the Gothic cathedrals, which is around 1000 to 1500 AD, which still stand today, is a testimonial to the ingenuity of their builders. So, biruin mo sa tagal na yung mga structures na yun, so hanggang ngayon nakikita pa natin sila. So ganun kagagaling yung mga engineers noon. Ewan ko lang ngayon kung bakit yung mga asada mabilis masira, tapos yung ibang karsada gawa pa sisirain. Alam niyo na Okay, so tingnan natin kung ano yung mga structures na ito. So ano ba yung mga structures during the early civilizations? So ito siya. So we have the Great Pyramid of Giza. So ito is yung burial place ng mga pharaoh or the resting place. Next, we have the Parthenon. So I believe this is dedicated do sa mga Diyos nila, do sa mga Greek goddess and goddesses. So this is for Athena, Parthenos. So this is considered as a holy place in the Greek civilization. So meron tayong mga cathedral, the Notre Dame Cathedral. So ito is commonly seen in Europe. And we have also the Roman Colosseum. So dito nagdoduelo yung mga hindi naman Spartan. So ito yung amphitheater built during the Roman Empire. So sabungan. Okay, next. So, alamin naman natin yung mga tao na nag-contribute ng kanilang buhay sa pag-develop ng ating structural analysis. So, ang pinaka-father dito is si Galileo Galilei. Next slide. Okay, so Galileo Galilei, so from 1564 to 1642. So he is generally considered to be the originator of the theory of structures. So sa kanya nag-originate yung pag-aaral ng theory of structures. So he has a book entitled Two New Sciences, which was published during 1638. So during that time, Galileo analyzed the failure of some simple structures, so including the cantilever beams. So ano nga yung itsura kapag sinawag natin na cantilever beam? Cantilever, so tama, naka-suspend siya or overhang. Nakalawet, guys, nakalawet.
Sarap.
Although Galileo's prediction of strength of beams were only approximate, his work laid the foundation for future developments in the theory of structures and ushered in a new era of structural engineering, in which the analytical principle of mechanics and strength of materials would have a major influence on the design of the structures. Okay, so next, dumako naman tayo sa second half of 17th and 18th century. Sino ba dito yung mga contributor when it comes to structural analysis? So, yung iba dito siguro familiar kayo since na-discuss na siya from our previous subject of previous course. Okay, so siguro familiar pa kayo dito. Last time lang natin siya tinake. So, we have Robert Hooke, o ano nga siya? Anong dinevelop niya? Yung Hooke's Law. The applied force is directly proportional dun sa deformation na mangyayari. Okay? So, Robert Hooke, so from 1635 to 1703, developed the law of linear relationship between the force and deformation of materials, commonly known as the Hooke's Law. Next, seryoso naman ito. So, we have Sir Isaac Newton. So from 1642 to 1727, so he was the one who formulated the law of motion, yung three law of motion, di ba? And developed calculus. Aba, siya pala yun.
Parang may maganda.
Next, we have Johann Bernoulli. So from 1667 to 1748, and he was the one who developed or formulated the principle of virtual work. Ang virtual work, mas maunawaan niyo siya upon sa pag-progress natin dito sa course na ito. I-discuss rin naman to. And last, we have Leonard. So, ang basa dyan is Euler. So, from 1707 up to 1783. So, he was the one who developed the theory of buckling of columns. So, when we say buckling, bumigay. Buckling of columns. Buckling, parang ano siya, na-compress, nagkaroon ka ng pag-buckle sa column mo. Yun yung commonly na nagiging failure ng columns natin. Okay? So, meron pa pala tayong isang guy here. So, next slide. So, he is Charles Augustin de Coulomb. So this guy, he presented the analysis of bending of elastic beams. So from 1736 to 1806. So bending. Na-discuss natin to before. Bending stress, flexural stress. Okay, next. Dumako naman tayo sa 19th century. So ito yung mga tao na nag-dedicate ng kanilang buhay sa pag-develop ng structural analysis. So first, we have Claude Louis Marie Navier. So from 1785 to 1836. So he published a treatise on elastic behavior of structures in 1826, which is to be considered to be the first textbook on the modern theory of strength of materials. So siya pala yung pinakaunang gumawa ng textbook about the theory of strength of materials. So Claude Louis Marie Navier. Next, we have Bernard Paul Emile Clapeyron. Silent yun eh. So, from 1799 to 1864, and he was the one who formulated the three-moment equation for the analysis of continuous beam. So, later on, pag-aaralan natin to. So, don't forget this term, the three-moment equation. So, ito is ginagamit sa mga continuous beam. So, pag continuous, from the term itself, continuous siya. So, you have several supports supporting several beams. Next, we have James Clerk Maxwell. So, from 1831 to 1879, and he presented the method of consistent deformation and the law of reciprocal deflections. So, the fourth one, we have Heinrich Müller-Breslau. So, from 1851 to 1925, and he presented the principle of constructing the influence lines. The influence line, ito later on i-discuss natin sa theory of structures. So, papasok na dyan yung moving loads. Gumagalaw yung loads mo. Usually ginagamit sa pag-design ng mga bridges. Okay, next! We have Charles Ezra Green. So, from 1842 to 1903. Stig yung mga bigote nila no? Buhay na buhay. Develop the moment area method. So, I think familiar pa kayo dito since ginamit nyo siya doon sa last topic in mechanics of deformable bodies. Moment area. Sa pagkuha ng deflection. Next. So, dumako naman tayo sa 20th century. Next slide. So, during the 20th century, so we have George Amani. So, from 1888 to 1947, and he was the one who developed the slope deflection method. Ayan, so itong slope deflection, huwag kakalimutan kasi magkikita kayo niyan dito. So, ito ay nasa medyo padulong chapters, which is considered to be the precursor of the matrix stiffness method. And we have also Hardy Cross, so from 1885 to 1959, and he was the one who developed the moment distribution method, o mas kilala sa tawag na MDM, okay, in 1924. So, ito napakahalaga ng MDM kasi ginagamit siya sa pag-analysis o pag-analyze ng complex frames. So, the MDM provided engineers with a simple interactive procedure for analyzing highly statically indeterminate structures. This method, which was the most widely used by structural engineers during the period from about 1930 to 1970, contributed significantly to their understanding of the behavior of statically indeterminate frames. Ayan nga. So many structures designed during that period, such as high-rise buildings, would not have been possible without the availability of the MDM or the moment distribution method. So ganun pala yung importansya ng MDM. So without that, hindi itatayo yung mga high-rise buildings natin noon during that time. Okay. So what is the use of this computer application? So before kasi manual lang yung pagsosolve ng ganyan o pag-design ng ating mga high-rise structures. So, with the use of the computer, so alam naman natin yung computer, ang role niya, instead na yung mga computations mo which aabutin ng days or even weeks, pinapabilis niya. Siguro minutes lang or even seconds because of the computer applications. So, ano yun? Ba? Isang word lang yata to no? So, basahin natin yung word. The availability of computer in the 1950s revolutionized structural analysis because of the computer could solve large systems of simultaneous equations. Analysis that took days and sometimes weeks in the pre-computer era could now be performed in seconds. So, the development of the current computer-oriented methods of structural analysis can be attributed to, among other, so ito yung mga tao na contribute doon sa computer applications. So siguro sila yung mga ng mga software. Okay, so next video natin, putulin muna natin since medyo mahaba na. So para magkaroon din kayo ng break, will be the roles of the structural analysis in structural engineering. Okay guys, so this is the part 1. So next video natin will be part 2. Thanks for watching.